In this video clip, let's look at this example. Find an approximate value of the root on interval 1 to 2 for equation 2 to the x plus 3x equals 6 at accuracy 0.1 with the bisection method. We can notice that 2 to the x plus 3x equals 6, this equation can be converted to the one right here. We can do this is because if original equation both sides is subtracted by 6, then right-hand side positive negative 6 will be cancelled to 0. And then left-hand side is 2 to the x plus 3x, then minus 6. These two equations, then the corresponding function would be y equals 2 to the x plus 3x minus 6. So finding the 0 point or x-intercept of this function graph is equivalent to find the root of this equation. Now we know between 1 and 2 there is a x-intercept, or there is a 0 point. Then we can be sure there is a root between 1 and 2 for this equation, or the equation right here, original equation. 1x is 1, this value. So 2 to the 1 is 2 plus 3 times 1 is 3. So 2 plus 3 is 5 minus 6 is negative 1. So 1x is 1, we have y is negative 1. And 1x is 2. We have a 2 squared is 4 plus 3 times 2 is 6 minus 6. So we have a y is 4. So between 1 and 2, then for sure there is a x-intercept or 0 point. The 0 point again will be the root of this one. And we use the middle point of 1, 2, which is 1.5, to approximate the x-intercept or the 0 point. And apparently, when you plug in 1.5 into the equation, you get that this number is not 0. So let's work on this through Tier 83 calculator. You input the equation 2 to the x plus 3x minus 6 first. You may graph it. You see the graph looks like that. Okay, looks like ours is right here. And then you can calculate as second calculation. One is to find out the value. If you input 1.5 here, you hit enter. You have a y value is 1.3284. 4 is less than 5, you can drop it. Okay, so here you have 1.328. You can also input 1 here, and here you input 2, and you hit M. That will be the middle value. And then if you hit f of m equals, it's going to be 1.328 something. So here you can use either calculator or the ebook function. Okay. Now we have a 1.5 f 1.5 right here is not 0. So apparently 1.5 cannot be the approximation of the 0 point, because it's far more greater than 0, 1.328. So 1.5, you plug in here, you have a value is a little bit above 1. You play the animation between 1 and 2. You have a middle point here, 1.5 here. You plug in 1.5, you have a 1.328. Since x is 1.5, you have a y value greater than 0, 1.328, then you know the root will be between 1 and 1.5. Okay, so the next interval will be 1 and 1.5 here. Okay, now you can see that you wanted to choose the middle point between 1 and 1.5 to approximate the 0 point. Okay, so you may do that. It's 1.25. That's the average or the middle point of 1 and 1.5. You have a function value here. Do we get this function value? Again, you can do this in two ways. One is the first value is 1. The second value is 1.5. So you may put 1.5 here and click on m equals, that's the middle point, and then you click on this icon. You have a 0.128. 4 is less than 5, you drop it. You may also turn on your calculator. You see the calculation is right here. You may input 1.25, hit the enter. That's the same thing as 0.128. Again, this value is closer to 0. Then you know 1.25 is might be the 0 point, but you know this value is greater than 0.1, so it has not arrived, has not reached the accuracy 0.1 yet. Okay, we need to find a value which is less than 0.1, then we can be treated. This value then can be treated as a 0 point. So we keep going. And then you see the next one will be 1 here and 1.25 on the right of this possible root x-intercept. Okay, and this time you see if you choose the middle point of these two, it gets a little bit far away from the root. So intuitively you can see that. The middle point of this 1 and 1.25 is 1.125. Your function value is right here. Okay, so this value is not 0, and then again you have to keep going. You have to keep going. So you do is that in this time, What is the interval? This value is negative for 1.125. So then this point will be the interval on the left. So U2 will be 1.125. And the right-hand side, U2 will be 1.25. So it will be 1.25. Okay. And then you hit enter. That will be the 0 point. Okay. And then you hit enter, it will be the value. Animation is like this. 1.125 is this interval on the left. Boundary point on the left, and then 1.25 is the boundary point on the right. Okay, then you do the next slide. So then you have the middle point, and then you have the function value. Again, you can also do this by calculating 1.185. Hit enter, you have a value 1.1875. So 1.1875. You hit enter, you have a negative 1.1599. That's approximately negative 0.160. If you round, this 9 is greater than 5, so you round it up, but this 9 plus 1 is going to be 10. And then 5 plus 1, you got 6. The original one, you keep it. Okay, again, this value is still greater than absolute value, still greater than 0.1, so you have to keep going. Again, then you do the next slide. Okay, next slide will be this point will be the left boundary. And then the right boundary is 1.25. Okay, the middle point will be 1.2185, and the function value will be negative 0.16. Okay, so right down here, then you may input the left boundary 1.1875. What you may also input directly here is what? Like here will be 1.21875. You hit this icon, you have a negative 0.016. That's the value right here. Okay, so up to this point, you see the absolute value of negative 0.016 is less than 0.1. So you can then treat this one as a 0 because the accuracy has reached. Okay, so then this value x can be treated as a 0 point. Okay, so our solution will be 1.21875. That will be our approximate value. Okay, so you can see down here is quite close now. It's quite close. All right, please review this lecture. I'll see you next time.